Hello friends, welcome to Skill Raptor. Uh, we are going to simulate a shortcut distillation column in the open source software DWSIM. So, before I proceed ahead, I would like to make an appeal that please like and share my video content. This gives me a lot of encouragement to make more and more videos. So, these videos are targeted towards helping students to actually get a job because you might know that theoretical knowledge may not be enough to get a job because skill is something that should be tangible. So tangible is a software here, so you should be able to use a software and demonstrate your chemical engineering skills. So let us proceed ahead with today's simulation where we are using a distillation column, calculate minimum number of stages, calculate minimum reflux ratio, and calculate optimal feed stage location. So let's see what we are going to distillate today. So our major chemical compounds are benzene and toluene. The thermodynamic package which we will be using is Raoult's law. The molar flow rate is 100 kilomole per hour at 1 bar pressure. Benzene and toluene fractions are zero point 0.4 and zero point 0.6. The method which we will be using to do this calculation is Fensky-Underwood-Gilliland. The reflux ratio is 1.4 times minimum reflux. So reflux ratio is 1.4 times of the minimum reflux ratio which we want to use. So here the light key compound is benzene and heavy key compound is toluene. So it is important to understand this because the light key component we will be getting it in the distillate, and heavy key mostly it will be in the bottom, and the product will be distillate and bottom which is 0.99. So maximum distillate will be getting, and bottoms will be a bit less. So let's go to the DWSIM interface. So here is the DWSIM software. I have already opened it. I will click File, New Steady State Simulation. This window opens. Click Next. I will type benzene. Click on the box to select the component. Then type toluene. Click toluene. Then press Next. Property packages. So as I said, we'll be using Raoult's law. So double click on the Raoult's law. Press Next. System of units, I am using C5. And remember that pressure is atmosphere here. So select pressure as atmosphere. Rest is okay. So I will click on finish. Let me just maximize this window. I will add a material stream which is a feed stream. I am clicking. I will just configure this. I am giving it the name feed stream. Then let's come down to flash spec. So temperature and pressure is generally given by default. So just change it to pressure and vapor fraction. Temperature is pressure is 1 atmosphere, and mass flow is 100. Sorry, uh, the molar flow is 100 as we have said. So the other things they will change automatically. Compound amounts, basis is mole fraction. As we said, zero point 0.4 we are assuming for benzene and zero point 0.6 we are assuming for toluene. Click on accept changes. Then the next step is to select columns. In this bottom side, you can see the columns tab. Just click on that tab, and here is our tab. Here is the one which is required, that is shortcut column. Now two more streams are required. That is, one is distillate and other is bottom. So I'm adding two material streams, just drag and drop there. Now the next task is to add energy stream. There will be two energy streams which will be required. One is for the condenser and other is for reboiler. I will just rename it. So this upper one, which is a distillate stream, which is a product stream, let me just give it the name distillate. And the bottom material stream is I'm writing it as bottom. Now the upper energy stream, which has to be C C energy, and the bottom one is for reboiler. So I will just write R energy. Okay. Now let's configure our distillation column. So feed stream. So under connections in feed stream, click feed. Then distillate stream, click distillate. Then bottom stream, click bottom. Then condenser duty is C energy, and reboiler is R energy. Now I will have to specify light key compound and heavy key. So light key is benzene and heavy key is toluene. Light key mole fraction in bottom is 0.01, and heavy key mole fraction in distillate is 0.01. So just type 0.01 and press enter. So reflux ratio here is 1.5, which is by default. So let's see how it affects our simulation. The next is condenser type. So it can be total or partial. So here by default we are taking total. Then condenser pressure is 1 atmosphere. Write 1 and press enter for both. So now my all the streams and the distillation column itself is configured. So I will try to solve this flow sheet now. So on top in the top bar, just click solve flow sheet. You can see the results which are displayed. So minimum reflux ratio is 1.655. Then minimum number of stages is 10.16. Now actual number of stages and optimal feed stage is it is showing error. The reason is the minimum reflux ratio is 1.65, and what reflux ratio we are considering is 0.15. So as we said that our reflux ratio will be 1.4 times of minimum. So I will change that here, 1.655 into 1.4 and press enter. So 2.317 is the reflux ratio which comes out. You can see different parameters are now generated for this. I will just check everything again. You can see as we said that we wanted to calculate minimum reflux ratio, that is 1.655, then minimum number of stages, that is 10.16, and optimal feed stage, that is 8.78. So around in ninth stage I think the feed location we calculated. So we saw how to simulate a shortcut distillation column, find out minimum reflux ratio, minimum number of stages and also optimal feed stage. So thank you for watching this video. I will request you once again, please kindly like, share my video content. This gives me an immense encouragement to make more and more such videos which will be helpful to develop skills. So thank you very much. Tata, bye bye.